In this video, we'll be talking about reactions of alcohols, ethers, amines, thiols, and thioesters. For the first reaction, we have a tertiary alkyl halide with a weak base and nucleophile. This means the reaction will be SN1. Therefore, the first step is to have the leaving group leave and form a carbocation. Since we have a 4-membered ring, and ideally we want a 6-membered ring, we can do a ring expansion. Here we have the bond between the 3 and the 4 carbon is going to come down and open and form a bond between the 3 and 5 carbon. This will shift the positive charge from carbon 5 to carbon 4. If I redraw the structure, this is what you get with the ring expansion. Next, we can do a methyl shift to turn the carbocation into a tertiary one. And now we can attack with our nucleophile For the next one, we have a secondary alcohol with PCO3 and pyridine. For this reaction, we are going to be forming an alkyl halide. However, we are going to have an inversion of the configuration with the alkyl halide. Now, if we had a nucleophile, such as methanol, the final product with a nucleophile would be an SN2 reaction, where you would retain the configuration. If we use something like TSCl, we would get an inversion. For the next one, we have a quaternary ammonium, and this is going to undergo elimination, specifically E2, and this is going to be called a Hofmann elimination. For a Hofmann elimination, we need to remove a proton and which proton we remove is going to be on the beta carbon that has the most hydrogens. So here are our 2 beta carbons. These are our alpha carbons. On our beta carbon here, we have 1 hydrogen. On this beta carbon here, we have 2 hydrogens. Therefore, we will take a hydrogen off of here, form a double bond, and remove the bond from the carbon and the nitrogen. So the final product will look like this. this opened up the ring and formed a terminal double bond. For the next one, we have an ether reacting with Hi. For this reaction, this is going to be an SN1 because we are going to form a benzyl cation, which is going to be stable. The oxygen is going to get protonated, and then the bond will break here to form this carbocation, and then to also form a primary alcohol. The carbocation will then react with the alkyl halide to form this. For the next one, we have an epoxide reacting with CH3O-. So our epoxide is asymmetrical, and we have a negatively charged species right here. Since we have a negatively charged species, we are going to attack the least substituted carbon. Therefore, this is going to react with this carbon here for the final product. For the last one, we have a primary alcohol reacting with SOCl2 and pyridine. So this will not give any rearrangement, and this will be a simple swap between the hydroxy group and a chlorine atom. This will be an SN2 reaction, and you will be forming an alkyl halide. That concludes the video on reactions of alcohols, ethers, amides, thiols, and thioesters.